third and final segment of Chapter 10, Acids and Bases. And this segment is solely on buffers. So it's just a couple of slides here, won't take too long. Not worrying about doing any buffer calculations, so this is all going to be conceptual. So a buffer is a solution that will resist pH change when small amounts of acid or base are added to the solution. So a buffer then is going to be comprised of a weak acid and its salt, and that way when we add acid to it, the salt will help to neutralize the acid. And if we add small amounts of base to it, the acid will react with the base to neutralize that, leaving the pH unchanged in most cases, or just a little bit of a change. So what do I mean by its salt? Well, let's take a look at a weak acid. So vinegar is a weak acid we're very familiar with. We've used it in the past to explain a couple of other different processes, but we know it's going to be the acid of the acetate. Okay, and so of course that's my protic hydrogen here on the end. We can put that into a double-headed arrow here with H plus the acetate, the C2H3O2. Of course, that's going to be a minus charge. All right, so what is the salt of the weak acid? Well, what I can do is add sodium acetate. All right, so now I'm going to add sodium acetate. That would be the salt of the weak acid. And now, what's happened? Well, I still have H plus in my solution, but now I've increased the amount of acetate. Okay. Now, up here it says it's going to resist the change in pH. So we can actually set our buffer to be any pH we want, and then it's going to resist it. So it's not that it's never going to change. If I keep adding acid to this, the pH is going to go down. If I keep adding base to this, the pH is going to go up. What's going to happen though is it's going to resist it at first. Okay, now it has to be a weak acid because we need this equilibrium component. We're going to need to have both the acid and the conjugate base in solution at the same time. Oh, there's some terms way back segment 1, right? So the conjugate base will help to neutralize acid. And of course, the acid that's in there will help to neutralize some of the base before the pH, the H plus itself, is actually going to be changed. Now, I also mentioned we could do this at any pH. So you might be thinking to yourself, well, would I still use a weak acid? And of course, no. If I want the pH to be set as a base, I can't use an acid to do that, which means I can play the same game with a weak base and its salt. And of course, we can break this down and take a look at the reaction itself. We have HA plus water goes to H3O plus A minus. And now, if I add hydroxide, I have HA there to help neutralize that. And if I have H3O plus, if I add more acid, then I have the I have the A minus there to help neutralize that. Okay, so again, that's why we have to have the salt. So the sodium, in essence, will not affect the pH, but will add an extra molecule of acetate to the solution. Right? All right. Now, where do we use this, or why do you need to worry about it? Well, the most common place where we see a buffer system is going to be in our blood. Our blood pH has to be in a certain range, and so our body then uses bicarbonate, the buffer of that system, in order to keep our pH balanced on our blood. Right? So oxygen, of course, is transported primarily by hemoglobin in the red blood cells. CO2 is then transported both in the plasma and the red blood cells. And so you can see here we have our weak acid. And of course, that's going to break apart to H plus and the bicarbonate. And of course, if I use sodium bicarbonate, then I have more bicarbonate in the system. And of course, that's going to help to offset any acid or base. So now if I add an acid, H plus, I have the carbonate here that can react with that, turn that into that one, which then forces it to come back out as CO2 and water, right? And of course, if I add a base, then I have the weak acid here to react with the base. So that way my pH in my blood will stay controlled, right? Now, of course, again, if I keep generating too much acid or too much base, then I can go into acidosis or alkalosis. And so it's not going to be perfect if I keep putting more and more in there. It's not going to work. It's going to eventually give out. But at least this way, you can have some acid and then have that, oh my gosh, the conjugate base there to help reduce it. And then on the other side of that, if I add too much base, I don't think our blood actually goes basic too often, but what can happen is you can go into acidosis. That's a very good possibility with different substances and different issues that we could have in our body. All right, so hopefully, again, you don't have to worry about calculations. If you Google some of this buffer stuff, you'll see Henderson-Hasselbalch equation. So if we wanted to, remember I said you could set your pH to be whatever you wanted. That would be the equation you'd use. So you decide what you're going to use in order to set your pH and then where you want your pH to be. And the Henderson-Hasselbalch equation will allow us to determine what the concentrations need to be for our weak acid in the salt. All right, so that's going to wrap up this chapter. As far as testing goes, you want to make sure you can do your pH calculations, make sure you can do pOH calculations, make sure you can balance the neutralization reaction. For Chem 110, you want to make sure that you can do the titration calculations. Right, and then for the buffer, it'll just be concept. So you want to make sure you know that you need a weak acid and why it needs to be weak, right? So you can't use a strong acid. And I'll let the cat out of the bag on this one. If I use a strong acid or a strong base, remember those completely dissociate, and that won't help us. We need that weak acid or that weak base to stay in solution so that it can react with either the acid or the base that might be added. All right, so if you've got any more questions about this stuff, feel free to get a hold of me. Again, a quick third segment, just this last concept of buffers. I believe next we'll be moving to organic chemistry. So we're almost finished. We have 2 chapters left, the organic chemistry, and of course, for Chem 110, you have nuclear chem. For Chem 100, that's it. So we just have the organic piece left. So stay tuned for that. That'll be in the weeks to come. All right, have a great one.